All right, so in module 1, lesson 1, we looked at different rates of speed and different prices of things, okay? And we looked at rates of speed that maybe didn't make sense to us at first. It might have been like 48 miles in 6 hours, okay? We then turned it into unit rates, and we took 48 miles divided by the 6 hours. What's 48 divided by 6? 8. And it would be 8 miles per hour, okay? Now, remember what we did with our hands. Everybody remember what we did with our hands? We were typing rates of speed. What was in the numerator? We do with our hands distance divided by time, okay? Again, everybody do that. Distance divided by time in the denominator. Time is normally always in the denominator, okay? And we find out our miles per hour, our feet per second, or whatever. Then we talk about costs, and we had different things that we need to pay attention. What was in the numerator then when we're talking about finding the best buy? Dollars. So we do dollars, everybody do that with their hand, divided by what you get, okay? Dollars divided by, so how many dollars you spend divided by whatever you got with it. And we can find unit prices, and we looked at on Monday how to find the unit price and get the best buy, right? We don't like getting ripped off. So here's the deal. We're going to kind of do the same thing here, but we're going to look at multiple rates and see if there's something the same with all of them. Now, this first example, I like it. It's a new self-serve frozen yogurt store opened up this summer. Now, we used to have a self-serve frozen yogurt store in Kearney. Does anybody remember the name? Remember the name?
Toppers.
Toppers. Toppers was really cool. They had all kinds of different flavors of yogurt. They had all kinds of toppings you can use, and it was so good. You could be healthy-ish if you wanted to, or you could just have tons of sweets. I took my boys there a couple times, but then we never went back. Why? It was so expensive, okay? What you paid was how much you got in the bowl. The heavier the bowl, the more it cost, okay? The weight was then factored in, and that's how much you paid. So we'd go in there for a family of 4 at the time. It'd be like $40. Is that a little too much to spend on ice cream and yogurt? Yeah, but it was a nice treat. We'd do it from time to time. Yes, Tristan?
Isn't it just like juice straw?
Is it like what?
The juice straw?
No, but that's expensive too. And they have a variety of things, but you don't do self-service. You can have things and they make it put it. So this would be you get an empty bowl, you fill it up with whatever flavor yogurt you want, whatever toppings you want, you weigh it, and then they figure out the price. So here's the deal. Each family member of Isabel's family weighed their dish, and this is what they found. Would you go with your family, Isabel? So far, every name that we've had has been somebody in a class. And it's Isabel's turn today. So now, one person had 12.5 ounces, it cost them $5. Another person had 10 ounces, $4. 5, 2, 8, $3.20. Which one would you have been?
8.
Would you have had the most ice cream or the least? Isabel?
I don't know.
She doesn't know. All right, so here's the deal. We need to figure out, is there a relationship between all these? So we got to find a connection between these numbers. And what you're going to do, in most situations, you're going to find, what did I do to this number to get to that number? Okay? What did I do to the top number to get to the bottom? What did I do to 10 to get to 4? What did I do to 5 to get to 2? What did I do to 8 to get to 3.2? What's the matter? Sorry, video watchers. We just had somebody spill water. Get some paper towels. Do we have a lid? All right. So now, what did we do? Sometimes you can see it. Sometimes you can look at it and go, oh yeah, I know exactly what they did. But this number is not the easiest number to see. What you can do to figure that out is reverse the order. What is 4 divided by 10 in your calculator? Go to your calculator. 4 divided by 10. If you don't have a calculator, buying a calculator would be a great investment, $10, $15. Or you could use your Chromebook. But if you abuse your Chromebook and you're doing other things on your Chromebook than using the calculator, we would take your Chromebook away.
Can I put my bag?
No. So, what'd you get in your calculator?
4 cents.
0.4, 4/10. Very good. Now, let's check and see here. Let's reverse here. What's 2 divided by 5?
0.4.
Oh, let's have the far side of the room do 3.2 divided by 8. Let's have this side of the room on my side do 5 divided by 12.5. Reverse the order. Do you get 0.4?
Yeah.
Yes. Here's the deal. Every one of these, and what we do, we found that number. We would take, now in your calculator, 0.4 still in there. Just hit multiply by 12.5. Take 12.5 times 0.4. What do you get? 5. Here, when we take 10 times 0.4, guess what we get? 4. 5 times 0.4. What's 5 times 4? What's 5 times 4? 20, but it's not 4.4, so it'd be 2. This one, 0.4. We're multiplying all these by 0.4. When you multiply all of them by the same number, we would say the cost is proportional to the weight. Proportional to the weight. Yes? Question?
What is the third? 0.4.
Oh, they're all 0.4. Absolutely. Did I tell you that it's tough to write on this thing?
Yeah.
So my numbers, but you gotta listen. They're all 0.4. But if any of them were different, then guess what? Not proportional. Do you know I charge by the amount of paper towel you use? Just like the yogurt place? Yeah, it's true. All right, now here's some other information that we need for this, okay? When we're talking about situations like this, we need to think of like what's going on with the situation. We need to understand what's going on. And in this case, we have some new terms. The book doesn't really talk about them yet, but I'm going to introduce them to you right now. We have what are called dependent variables or situations, dependent, and we have independent. Okay? Dependent and independent. Right now, little Hayes, is he dependent or is he independent? He is very dependent on us, right? We have to change his clothes. We have to feed him. We have to help him burp. We have to wash him. We have to do all kinds of stuff. He's pretty good at crying on his own, pretty good at pooping and peeing on his own. But he is very dependent on us right now, right? When you were little, you were immensely dependent on your parents, right? They did everything for you for many years. But as you got older, you could do some stuff on your own. Now that you're even older, you should be doing things like helping take out the trash, helping do things around the house. You're becoming more and more independent, right? And the more independent you are, the better off you are, because in about 10 years from now, do you still want to be living at home?
No.
Probably not. You want to be out of college maybe, or into a job somewhere, living on your own, being independent, okay? So here's the deal. Just remember, when your parents are telling you what to do, you're still dependent on them. Be good and considerate and do what they say. Because they took care of you for many years doing things that you couldn't do on your own. But now you can, so start doing that stuff. It's important. Now, I'm pretty old. My parents are 80 and 82 years old. Okay? Am I still dependent on them for things?
Yes.
Yeah. There's times I call up and say, well, what should I do here? What about this? What do you know about this? I call them. I depend on them. But it's also reversed. They depend on me. They used to live in Beatrice, and we were pretty independent of each other. I'd see them maybe once a month or every 2 months, maybe 3 months. Now they live here in town. I see them hopefully about once or twice a week. They now depend on me for certain things, all right, like groceries. During the whole shutdown thing, I didn't want them going to the grocery store, so I would do their grocery shopping for them. I'd do like online orders, and then I'd deliver it to them, or they'd come and get it for me. So it's kind of a reversal. Hopefully later on, your parents are kind of dependent on you for certain things because you become experts in things, all right? So we're working that transition to go from dependent to independent. But here's the deal. The variables are always going to be dependent or independent. And what they tie to is here. So now we want to ask, does the weight of your yogurt depend on the cost? Or does the cost or amount you pay depend on how much your yogurt weighs? Yeah. So here's the deal. We got to figure that out. The cost depends on how much yogurt weighed. Okay? Does that make sense? The amount you pay depends on how much yogurt you get. You get a lot of yogurt, pay a lot of money. You get a little bit of yogurt, pay less money. Does that make sense? The cost depends on that. Okay, now we're going to assign variables to these, and they're going to be pretty consistent, and they're variables that are used quite often. Do you know what the two most used variables are? You've probably seen them. They're towards the end of the alphabet. X and Y. Very good. So here's the deal. Your weight is going to be called the X. The cost is the Y. Now, I'll tell you right now, when they set up the tables, most of the time, the X is on top, the Y is on the bottom. So now, cost depends on the weight. Cost is also the Y. So what we could do here, we could say the dependent variable is the Y, and the independent variable is the X. Now notice how I wrote my X and my Y. If I were to write this, what does that mean? Multiply, right? So if I see a plain, straight-lined X, that means multiply. Okay? Do I want to confuse with a variable? No. And here's it. We're going to be moving away from using the straight line X. We might use a dot. We might not need anything. Right? Sometimes we don't need to put anything in between, unless we have like numbers. But if we have variables, if we don't have anything in between, it means multiply. Now notice I didn't write my Y like this. What does that kind of look like? Maybe if I, maybe like a 4, maybe like a fraction. It's confusing. But when you see this, are you confused by the cursive Y? No. Other letters that we try to stay away from, when I see an L, what would I do? I would do cursive. Okay? I don't want to get confused with that. When I see I's, instead of a straight line I do a little cursive I. Okay? So again, anything I write down, you're writing down. Some people are, some people are not. Okay? So we want to stay away. Now, here's the deal. We have an equation that we can write with every situation we're going to look at. And this equation is based on this form right here. We have y equals, we have a new variable we're going to introduce, which it actually is the same number every time we're talking this situation. We're going to call it the letter, what letter is that? That's the letter K. And it's going to be y equals k times x. Notice, did I use an x for multiplication? Now, I could use a dot, but I could just leave it blank. When I have two variables right next to each other, it implies that we're multiplying them together. Okay? And I didn't leave enough room up here. So we know what the y is. In this case, it's cost. That's the dependent variable. We know what the x is. We know it's the weight in this situation. We know that's independent. What that means is you can pick whatever value you want for the x. Doesn't matter. But whatever x is, it's going to kick out a value for your y. Y depends on how much you get. In this case, we have a special name for the k. Okay? And I believe you used this last year. It's kind of a long phrase. It's 3 words. The middle word is of. When I first started teaching Eureka, I could not spit this phrase out. I never had used it before, but I like it. And it ties into things you're going to do later on. It is called the constant of proportionality. Proportionality. Again, my handwriting's not beautiful, but hopefully you hear what I say and you can figure out how to spell it. Proportionality is written up on the board too. Okay? So that K is called a constant proportionality. Later we're going to change the K to the letter M, and you're going to use it when you get into algebra. Okay? But right now we're going to call it the K, the constant proportionality. And that constant proportionality is like the unit rate for the ice cream. How much is it for 1 ounce of ice cream? Well, we figured that out when we figured this number. Our constant proportionality is 0.4. So what I could do, my equation would be y, which is my cost. My cost is equal to, in this case, 0.4 times whatever my weight is, which we call x. So if my weight is 5 ounces, go to your calculator. What's 0.4 times 5 ounces? 2. What if I'm like really hungry and I'm like hot and whatever and I want to eat a lot? I get 34 ounces of ice cream. Well, here's the deal. You have charts sometimes, but you can just figure it out. You can throw in there. 34. What's 34 times 0.4?
13.1.
What does it get in?
13.6.
13.6. Agree? So that is $13.6 or $13.60. Is that a lot of money for a bowl of yogurt? Yeah. And they used to have, I don't remember this, but they had like a wall, and it was like the wall of fame. And there were people in there that had the picture with their big old bowl of stacked high, and they cost like $40 for that bowl of yogurt. Okay? Oh, that's a lot of money. And again, we went there a few times, and we're like, yeah, we can't really afford this all the time. But it was a nice little treat. Okay? Now, one more thing that is very, very important. I'm going to point out on this one. We're going to see it pop up on future ones. A point is going to show up, and it's this one. It's 0, 0. 0, 0, and I put parentheses right there. Now, the first one is my x variable. The second one is my y variable. So the weight is 0. If I have 0 ounces of yogurt, how much does it cost? $0. That is very important when we're talking about proportionality. Okay? If I buy 0 ounces, I pay $0. Does that make sense? Okay? Does anybody know the name that we have on the coordinate plane for it? It's like in the middle. It's where the 2 lines intersect, your x-axis and your y-axis. What do we call the point specifically 0, 0? The what? The origin. Very good. That is the origin. All of the situations we're going to look at that are proportional, they go through the origin. If it doesn't go through the origin, guess what? It's not going to be proportional. Now, today they only give us examples that are proportional. Okay? But we're going to see that pattern. Now, after I talk to you about dependent and independent variables, they throw this problem at us, which really there isn't a dependent or independent variable, but you can assign one. In the back of a recipe book, they show you the conversions going from cups to ounces or ounces to cups. You can go either way. What we're going to do is say, okay, this is my x, which is my independent. The ounces are going to be my y, which means they depend on the ounces, just like we did above. Now, sometimes you can't see it, but can you see what I did to 1 to get to 8? What I do? Times 8. Is it true when I did it over here? What times 2 gives you 16? Times 8. Well, what's 1.5 times 8? What's 8 times 1? 8. What's half of 8? 4. What's 8 plus 4? Does it check? If I took 1/2 of 8, is that 4? Yeah. So it's all the same. The ounces are proportional. Proportional to the cups. Does that make sense? That's all we're checking. And you need to check every single one. If by chance one of them multiplied by 9, guess what? Not proportional. And we'll see that tomorrow. Okay? But today they're all the same. Now, what would my equation be? Well, it's y, which in this case is the ounces. The ounces are equal to, what is my constant of proportionality? 8. Perfect, Isabel. 8 times whatever the cups were, x. That would be my equation. Now I could say, what if I had 40 cups? How many ounces is that? Well, 40 times 8, that's 4 times 8, that's 32 with the 0, 320 ounces. Okay? Does that make sense? Good. So this one, again, that doesn't really have the dependent versus independent, but our next one does. You guys know Jose? Yeah. During Jose's physical education class today, students did different activity stations. Next to each station was a chart depicting how many calories, on average, would be burned by completing the activity. So this one's jump rope. If you jump rope for 0 minutes and 0 seconds, how many calories did you burn? 0. Does that make sense? If you jump rope for 1 minute, how many calories do you burn? 11. What do I do to 1 to get to 11? It's always multiplying, Kale. You bet. I multiplied by 11. Can you see that without having a calculator? We times 11. What do I do to 2 to get to 22? Times 11. Now, if you can't see it, reverse the order. What's 33 divided by 3? What's 44 divided by 4? Does that make sense? Okay. And again, we would say X is time, calories is Y. The Y was the what variable?
Y.
Y was the
Calories burned.
originally dependent or independent? Y is the dependent. Y depends on what X is. Okay? Do the calories you burn depend on how long you did your jump rope? Yeah, that makes sense. The time is not dependent. Time goes on no matter what. Time is not dependent on anything else. It is independent. It's always counting. It's always going forward. It's always counting up, so to speak. So that's always the X, and that is always in the denominator, right? When we did your distance divided by time. Now, is the number of calories burned proportional to time? Yes. Why? Because time is always, I'm going to abbreviate multiplied. If I just put mult, you know what that means? Okay? Is always multiplied by, in this case, what are we multiplying every time? 11. Does that make sense? Okay, you see that with the little table? It's kind of like a table. Now, Jose jumped for 6.5 minutes. Is it on the chart here? Can we figure out what 6.5 minutes is? No, but we have now a formula, so to speak. We know Y is equal to, what was the number I was multiplying every time? 11 times whatever X is. In this case, X is time. So we know now calories equal 11. Notice I am going to put a straight X. 11 times time. What's his time? 6.5 minutes. So this would be 11 times 6.5. Now, you got a calculator. You can use a calculator. Guess what? I'm going to show you a trick with 11s. I'm going to show you a trick you don't even need calculator. I'm going to show you. Oh, it's there. You're the first person all day to notice the sign that I have for the 11 trick. I'll teach you that soon. It is super easy, and it's very nice. So here's the deal. The trick is we multiply 11 times 6.5. We get what in our calculator? 71.5. Okay? And what's the label on that? 71.5 calories. If you jump rope for 6.5 minutes, on average, you're going to burn about 71.5 calories. Does that make sense? What if I jump rope for 50 minutes? Could you figure out how many calories you burn? Yeah. The time is 50. 50 times 11. You would be burning some calories. And probably very tired. I'd go about 2 minutes and I need a break.
550.
All right. Next page. Next problem. Alex spent the summer helping out his family, right? We just got done with summer. He was helping out with family business. He was hoping to earn enough money to buy a new $220 gaming system by the end of summer. Okay? Maybe you have a gaming system. I don't know what gaming systems. Maybe the Switch is that cheap. Most of them are a little more expensive. I know Lincoln's focus this summer when he was detasseling, he wanted to earn enough money to buy the new PS5 that's coming out later this year, they're saying. We don't know how much it is. He wants to save his money and buy that. So he's not buying anything else. He's saving his money. He's going to put money towards that, maybe a game or two. Normally, we would get we got the GameCube. Right as the GameCube was coming to an end, and they're making the next type of game system. We bought the PS2 when it went on sale because the PS3 was coming out. So usually we get the gaming systems towards the end of their lives, but he really wants a PS5. Okay. Well, this guy wants whatever gaming system. Now, he's saving his money. Halfway through the summer, after working 4 weeks, he had earned $112. Notice down here, we have a table. It says weeks that went by, and then earnings. We know after 4 weeks is $112. Alex wonders, if I continue to work and earn money at this rate, this is important, at the same rate, will I have enough money to buy the gaming system by the end of the summer? To to determine that, what you would need to do is organize a table. If I don't know where to give you a table, Keandra, you need to make a table. Well, they kind of made it for you. We put in after 4 weeks, 112. He knew at the end of 1 week that he earned $28. Okay, so far it gives us 2 bits of information. Now, looking at this table, if he worked 0 weeks, how much money did he earn? $0. Right? That is so important. So if you work 0 weeks, you get $0. When he worked 1 week, he got $28. What did I do to 1 to get to 28? Times 28. Okay? So here times 28. Okay? Now, is that true for the 4? What times 4 gives me 112? We'll try it. Do 4 times 28. 4 times 28, what do you get? You get 112. So here's the deal. Our magic number is 28. Okay? Our formula is y equals 28x. Our earnings, y, depend on how many weeks we worked, which is the x. Does that make sense? The more you work, the more money you get. So now what I want you to do in your calculator or in your head, fill in the rest of these. Okay? Fill in the rest of those. Some of you are done or almost done. Should I want you to do this a long way, do a long multiplication? No, use a calculator. Use your calculator, absolutely. Save some time and effort. Five weeks, how much money did he have? 140. 6 weeks? 168. 7 weeks? 196. And his final 8 weeks is what? 224. Who agrees with 224? Did you use your calculator? Good. Okay. So now, you work with a partner. Can I be your partner? Answer his question. Will he have enough money to buy the gaming system by the end of the summer? Does he have enough money? Yes. He has $224. Now, my question / concern, is that $220 including tax, or does he have to pay tax on top of that? Okay? And they tax everything that's not food at grocery stores. If it's food, you don't have to pay tax on it. But with other things that you don't quote unquote need, they charge tax. So here's the deal. This is what I do with my boys. They want to buy something big. I say, okay, I'll pay the tax for it. You pay whatever, I'll pay the tax on it. If he has to pay tax on that, he doesn't have enough money. But let's assume that's including tax, and he will be successful. Okay? Now, how much money is he earning every week? $28. Is that pretty good? That's not bad for a young kid helping out. $28 a week. I had old kid detasselers earn about $28 an hour. They were working hard. Okay? They worked hard. They got about $28 an hour. Some of my young kids that had never detasseled before, if they were good hard workers, they were there every day. They did their job. They didn't mess around. They earned between $800 and $1,000. That's why I say good workers. Really good workers. I had some kids first year, $1,400, $1,800 in 3 weeks. Okay? How much did he earn after 3 weeks? $84. Okay? My old kids, in the 3 weeks, some earned $3,000. If you work hard, you get paid really well with the tasking. But if you mess around, if you don't show up for work, if you don't work very hard, it's not bad money, but the tasking is not easy. It's not easy. It's not fun. But if you work hard, you can put up with the pain and anguish and getting up every morning, you can earn some good money. So here's the deal. When I was that young, I would love to have that money. But now you have opportunities to get other types of money. Now, are Alex's total earnings proportional to the number of weeks he worked? And how do you know? So it's a yes. That's a horrible yes. What did we do? The weeks were always multiplied by 28. And that 28 stood for what? 28 what?
$12.
$28. You got 28. And that's that constant of proportionality. Okay? Understood? Not bad. All of these were proportional. Tomorrow we'll look at some that are not proportional. Let's flip to the next page. Okay, now I noticed sometimes they put this in, sometimes they don't. Before they always had this at the end of the lesson. It's kind of confusing, and here's the deal. You need to be a pretty good reader to understand this stuff. I'm a pretty good reader, and yet when I read this, I get lost in their words. But I think it would be good before the test, kind of read over it, reread, and see does it make sense to you. So now, measures of one type of quantity are proportional to measures of a second type of quantity, the weight of the yogurt and the cost of the yogurt. If there is a number K, what did we call that K? Yes, Kale? Kale, look at the board. It is the constant proportionality. Very good. So that value K, so that for every measure of an X, of a quantity of the first type of corresponding to Y, it just says this is the formula we have. Y equals KX. Okay? That's what we wrote. That's what we'll see over and over and over. Now, a proportional relationship is correspondence between two types of quantities such that the measures of the quantities of the first type are proportional to the measures of the second type. That just means as you go across here, all the numbers are multiplied by the same thing. Okay? And that's what we need to verify. If, by chance, anytime it's a different number multiplied by it, guess what? Not proportional. It's that simple. Okay? So you're going to have to check that in the future. Note that proportional relationships and ratio relationships describe the same set of ordered pairs. What we have here, remember how I said 0, 0 with parentheses around it? We can turn these into points on a graph. We're going to look at graphs here in the future. Okay? But they're in two different ways. Ratio relationships are used in the context of working with equivalent ratios, where when we talk about proportional relationships, we're talking about like rates of time. Distance divided by time, right? Remember that? Rate of speed. In the example below, distance is proportional to time, and we can calculate that value, and we get the same value 10. If we look at these, what did I do to 1 to get to 10? We multiplied by 10. All right? What did I do to 2 to get to 20? Times 10. 3 to get to 30. All the same. What is my constant of proportionality? 10. My formula would be y equals 10 times, what is our variable normally? Y equals 10 what? X. But notice what they did. They said, oh, we're going to call times t. But we can call it x. We can call it whatever we want. Whatever variable we want to choose to represent, we can do that. And soon we're going to start varying the variables we use to make sense with what we're doing. Instead of y, what variable might I use to represent distance? D, right? Does that make sense? So all of them are this general form, but we're going to be able to expand it and be more specific with what we're doing. Okay? All right, we go to the next page. We're going to skip for now. We might come back to that. Don't worry about oh no, that's the next one. This one, I keep calling it a different name. I want to call it the hamburger helper. You ever had a hamburger helper? Yeah. Yeah, I enjoy some hamburger helpers, and every time I see this, it's homework helper. This is your homework. What I want you to do is read through this. They give you a problem, they give you a situation, they kind of talk you through it. There's nothing really you need to do with this other than go, yes, I agree. Oh, I understand that now. This is just reading through the problems, looking at what they're doing, understanding the relationships, verifying what you know. There's not a whole lot for you to do on these problems, but do them, okay? So I will want you here in a second or two to go back and look over this, read through that. That's part of your homework. And then let's go to the next page. This is your problem set. Don't worry about doing number 2. Okay? Do all the problems, but don't do number 2. Oh, there is no number 2. No, don't worry about doing it. Do number 1 and number 3. Okay? And this was a mistake they did in the previous book. I thought they might have fixed it, but let's look at this first one. I'll even help you on the first one. A cran-apple juice blend is a mixture in a ratio of cranberries to apples, 3 to 5. So down here, we're gonna fill in the table. How much of the cranberry do we put in there? 3. How much of the apple do we put in there? 5. Now that might be 3 ounces, that might be 3 gallons, whatever it is, it's 3 to 5. They want other values that are also true. What would be one other one? 6 to 10. You can come up with whatever one on your own. Would these quantities be proportional? And then you need to do John. This one's a little bit tough. You might draw a picture, but you need to figure out what's going on with John and what he's doing there. Okay? So, birth announcements due tomorrow. Your lesson 2 homework and the homework helper need to be looked over and done for tomorrow.